Okay, da? Good morning, all of you. Today I am going to explain the paper discussion. I hope you got good marks in physics. First question. The phenomenon which can be explained only by quantum nature of light. Quantum nature of light, that is a photoelectric effect. Photoelectric effect, first option. Second one, in which of the following emission of electrons does not take place? Actually, how many methods are there? 4 methods. First one is equal. What is first one is equal? So this is a thermionic emission. Second one is equal to photoelectric emission. Again, third one is equal to field emission. And again, fourth one is equal to secondary emission. So what are the types of emission of the emission of the electrons? So totally how many methods are there? 4 methods. So first one is equal to thermionic emission, second one is the photoelectric emission, again third one is equal to field emission, and again fourth one is secondary emission. So in this question, in which of the following emission of electrons does not take place? Here first option is given thermionic, second one is given photoelectric, third one is equal to given secondary, last fourth one is none of these. So which is the correct one here? Fourth option. Again, next third question. The wavelength of photon is 4000 angstroms. So lambda is equal to given third question. So lambda is equal to given 4000 angstrom unit. And find the energy. Energy E is equal to how much? So what is the formula? Energy E is equal to. So energy E is equal to h nu, or this is equal to hc by lambda. Okay, that frequency is not given in the question. So wavelength is given. So the energy E is equal to hc by lambda. I given one small technique also. So whenever the lambda is in angstrom unit, the hc value is equal to 12,400. That unit is equal to electron volt by this lambda must be in angstroms. So this is a one more equation. So now in this question, so lambda is equal to given 4000. So 12,400 by 4000. Check that options. All options are given joules only, joules. So this answer will become electron volt. Now we have to multiply with the, so 1.6 into 10 to the power minus 19 joules. What is the correct option? Fourth one. Do this remaining calculation. The energy E is equal to 12,400 by 4,000 electron volt. You have to convert into joules. So 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. Again, next one. Fourth option. Fourth question. What is the kinetic energy gained by electron due to acceleration through a potential difference of 1 volt? So this is nothing but definition here. This potential difference of 1 volt. So what is the kinetic energy gained is equal to here. So this one is equal to 1 electron volt. 1 electron volt. So what is the definition of the electron volt is equal to? What definition? The energy gained by the electron. So when it is accelerated through a potential difference of 1 volt. So this is known as 1 electron volt. So 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. Again, next. Fifth question. This sodium and copper have work functions are given. So one is fifth question. So W sodium is equal, this value is equal to 2.3 electron volt. And the next one is equal to 4.5 is given copper. So WCU is equal to say 4.5 electron volt. So what is the ratio of the wavelength is nearly? So what is the wavelength is equal to? What is that equation? This work function W is equal to hc by lambda, or W naught is equal to hc by lambda naught. Clear? So in this question, hc is equal to constant. So W is proportional to, so 1 by lambda naught. W sodium by W copper is equal to, this is equal to, so lambda again lambda copper by lambda sodium. Please do this calculation. So this is equal to, say, W sodium by W copper is equal to lambda copper by lambda sodium. You have to find out not exactly nearly value. What is the answer? 2:1. Next question. 7th question. 6th question. The work function of photoelectric substance is 3.3 electron volt. So W naught is given. So what is the threshold frequency is equal to? Question number 6th one. This W naught is given. This W naught is equal to 3.3 electron volt. W naught is equal to 3.3 electron volt. So what is the value of threshold frequency is equal to? So nu naught is equal to how much? So what is the formula? W naught is equal to H nu naught. So nu naught is equal to say W naught by H. Shall we do this calculation part here? So nu naught is equal to W naught by H. But I can check that options verification here. This W naught is given electron volt. So you have to convert into joules. So this value is equal to W naught 3.3 electron volt. So 1 electron volt, how many joules here? So this one is equal to 1.6 into 10 to the power of minus 19 joules. By H is equal to 6.62 into 10 to the power of minus 34. So joules second. Yes, to do this calculation part. What is the answer? 4th option. Okay, next one. In the photoelectric experiment, both intensity and frequency of the light doubled. Both frequency and intensity of the light doubled. So what about the saturation photoelectric current? So what about condition? The saturation photoelectric current depends upon only intensity of light. So only intensity of light. So it is independent of frequency. Frequency double, triple, anyone here. This photoelectric current should remain the same. It depends upon intensity. So intensity is a doubled means what happens? This current is also doubled only. So what is the option here? 3rd option. Okay. Okay, next one. Intensity doubled means photoelectric current is also doubled. It is independent of the frequency. Not the statement also. It is independent of frequency. Next. 8th question. Einstein's photoelectric equation E is equal to, or EK is equal to H nu minus pi. H nu minus pi. So in this equation EK refers to, so what is the meaning of EK is equal to? So what is that equation? The energy E is equal to say W naught plus kinetic energy maximum only. So this is the equation. The energy E is equal to W naught plus Ke max. So what is the Ke max equation? So Ke maximum is equal to E minus W naught. But in this question E is equal to energy, that is equal to H nu naught given, W naught is equal to pi is given. So this is equal to Ke max. So what is the meaning of the Ke max means? This maximum kinetic energy of the emitted photoelectrons. The maximum kinetic energy of the emitted photoelectrons is equal to H nu minus pi. So in this question, what is referred to the EK is equal to? So what is the option? So maximum kinetic energy of the emitted photoelectrons. So 3rd option. Okay, next one. So 9th question. If in a photoelectric cell, the wavelength of incident light is changed from 4000 angstrom to 3000 angstrom. So what is change in stopping potential is? This wavelength changes, 9th question, the wavelength changes from 4000 angstrom to so 3000 angstrom unit. The wavelength changes. Just imagine here, wavelength decreases or increases, so wavelength decreases only. So wavelength decreases means whatever photoelectrons is equal to. Again, so what about again stopping potential is equal to? The changes from 4000 angstrom to 3000 angstrom, the stopping potential will be. So what is that equation? The energy is equal to W naught plus K max. So energy is hc by lambda. So hc by lambda is equal to W naught plus kinetic energy is equal to E V naught. Clear this equation? So in this case, this wavelength changes from the 4000 angstrom unit to 3000 angstrom unit. So first point hc by lambda, first point. So hc by lambda is equal to, or this value is equal to 12,400 direct value. So 12,400 by, so lambda is equal to 4,000. Clear? So which value is equal to W naught. So W naught plus again potential is equal to E V naught. This is equal to simply E V1. Okay, next second case, second point. So whenever this wavelength changes from the 4000 to 3000 angstrom unit, so what is the lambda 2 value is equal to 3000. So 12,400 by 3000. So which value is equal to W naught plus E V2. So what is the change in stopping potential? Change in stopping potential means, so E V1, so V1 minus V2. So now again, so this is equal to equation 1, this is equal to equation 2. So now we have to do equation 1 minus equation 2, which implies. So equation 1 minus equation 2, which implies. Shall you do the remaining calculation? So in this case, 12,000 is a common, and in both cases 4,000, this is 3,000. So 1,000 also common. So 12,000 by 1,000. Again, remaining value 1 by 4 minus 1 by 3. I wrote direct equation. No need of 1 by 4,000, 1 by 3,000. Simple 1,000 is a common. So what is that equation? So 12,400 by 1,000. So which is equal to W naught. Again, this also minus. This is cancel only. So plus E into V1 minus V2. Shall you do the remaining calculation? So LCM 1 by 4 minus 1 by 3. So this 2 zeros are cancelled. So 124 by 10 into. So what is LCM is equal to here 1 by 4 minus 1 by 3. So what is the value is equal? This is equal to 4 into 3 is equal to 12. So again 3 minus 4, which is equal to E into, so V1 minus V2. Here this wavelength decrease means what happens? Stopping potential is also decrease only. Do this remaining calculation. What answer? What answer? 1.03? Yes, do it. We have to do simple calculation. Don't do large equations. Simple calculation. So directly have to write these equations. So first equation 12,400 again 4,000. So directly again 12,000 by again 1,000 is a common for both cases. So this is equal to 1 by 4 minus 1 by 4, which is equal to, so W naught is cancelled. So E V1 minus E V2, or E into V1 minus V2. So you should find out E into V1 minus V2. 1 point. This value is electron volt, 1.0, this value is equal to 1 point, how much value? 1.03 electron volt is equal to E into V1 minus V2. So electron and electron is cancelled here. So V1 minus V2 is equal to 1.03 volts. Okay, next one. Ninth one. Okay, next 10th question. 10th question. A monochromatic source of light operating at 200 watt. So power P is equal to 200 watt is given. Again, emits 4 into 10 power 20 photons per second. The number of photons per second is given, that is equal to n by t. Or n by t is equal to 4 into 10 to the power 20. So this is the number of photons per second. Find the wavelength of light is equal to. So what is the formula? This power P is equal to energy by time, or this is equals to N into E by T. Now what is the E is equal, what is the value? This is equals to N by T into energy is equal to Hc by lambda. Energy is equal to h nu, or this is equal to Hc by lambda. So what is that equation? N by T into Hc by lambda, Hc by lambda. In this question, lambda is equal to lambda given or given? We have to find lambda value. Yes, do it. We have to find a lambda value. Next one. What is the answer? 400. Very good. First option. Again, 11th one. 9th one, 10th one. Next 11th question. Compulsory, every student must write in the notebook, so not on the papers. Mention the heading. This is the exam 2 only, exam 2 date, syllabus. Write that all solutions. While going to write cumulative test, you have to check this all questions and solutions only. Okay, next one. 11th question. 11th question. Using light of wavelength, given, that is equal to lambda 1. So lambda 1 is equal to 6000 angstrom unit. So lambda 1 is equal to 6000 angstrom unit. Stopping potential is obtained at 2.4 volt. So this is equal to V0, V0 1 is equal to say 2.4 volt. So V0 is given. For the photoelectric cell, the wavelength they can change it to 4000 angstroms. Lambda 2 is equal to say 4000 angstrom unit. So now again, what is the stopping potential would be? Would be means here you have to find out this stopping potential. What is that equation? Lambda 1 is equal to given, initial wavelength is given. Using light of wavelength is equal to 6000 angstrom unit. Stopping potential obtained 2.4 volt for photoelectric cell. The light of wavelength, second case is equal to light of wavelength is equal to 4000 angstrom unit. Then what is stopping potential would be? Same this equation only. This equation same as this equation only. Okay, same this also lambda naught is cancelled, and again next one again V1 is given. We have to find out V2 value. Same we have to do this question. Same question. So first point is equal, first one 12,400 by, and this value is equal to 6,000 angstrom unit. So which is equal W naught. Again next one is equal to kinetic energy is equal to E V naught 1. So this is equal to equation 2. Again second point is equal to 12,400 by, the wavelength is equal to 4,000 angstroms. So which is equal W naught. So what is the kinetic energy is equal to E V naught. Same equation 1 minus equation 2, you have to do this one. Find out V2 value. Next one. Got the answer? How much? 3.43. Hello, don't see from this Q1, okay? Compulsory you have to do the solution. So simply answer key is given, so 3.4. So compulsory you have to do the solution. Okay now? Next, 12th question. No photoelectrons are emitted from a metal. No photoelectrons are emitted from a metal. If the wavelength of the light exceeds 600 nanometers, the work function of the metal is? Simple question only. So in this question, lambda is equal to given. So what work function is equal? What is the formula? W naught is equal to 12th question. So W naught is equal to Hc by lambda. Yes, do it. So lambda is given 600 nanometers, but you have to convert into convert into angstroms. So 6,000 angstroms. But again check that options, all options are given joules. So you have to multiply with the 12,400 electron volt means 1.6 into 10 to the power of minus 19 joules. So lambda is given, this value is equal to 600 nanometers. So that is equal to 6,000 angstroms. You have to do this method. Now sir, all options are given. Joules means simple logic. H is equal to 6.62 into 10 to the power minus 34. C is equal to 3 into 10 to the power of 8. Again, lambda is equal to 600 into 10 to the power of minus 9. You have to do any one. Okay, since options are given joules. Again, next one. Next question, 13th question, theoretical question, logical also. First point, when yellow light is incident on a surface. So first one is yellow light. 13th question, why? Yellow light is incident on the surface, no electrons are emitted, while green light can emit. So next one is called green. So what about wavelength between this yellow and green light? Both are same or different, or which value is the more? Which value is the more? So yellow and green light. Again, next one is given. If the red light is incident on the surface is equal, next one is equal to red light. So first one, whenever yellow light is used here, so no photoelectrons are ejected. This is given. Second one, whenever green light is given, green light used. So what happens here? This, while green light can emit, so electrons are emitted. Okay, next one, again, third point, the red light is incident on the surface. Electrons are emitted or not emitted? Not emitted. Why? So what is the condition? So this is equal to Vibgr. Okay. So among this all colors, red light wavelength is more. So this wavelength is more means what happens? This is equal to lambda r. Again, this frequency is equal to nu r. So again, next one is equal to violet is equal to again lambda v. So what is the value is equal? Lambda v is less than of lambda r. So among this all colors, so this violet color wavelength is less. So violet color wavelength is less means what about frequency? This frequency is equal to more. This frequency is more. So among this all colors frequency is more. Okay. Again, next one. So first point is equal to yellow is given. This yellow is given. So whatever this frequency is equal to nu y. So whenever yellow color is used, so no photoelectrons are used. Yellow used means no photoelectrons here. Automatically orange also used here, no photoelectrons. Red also used, no photoelectrons only here. Suppose one student got the marks is equal to 30 only. Simply again he failed here. No sir, I got 25 marks means I got double fail also here. Fail only here. Okay, one student again marks 30 marks, he failed only. One more student, sir, I got 25. What happens here? Again fail only. Same, this also yellow light is used only, no photoelectrons here. Again orange color, red color also used, no photoelectrons. Again among this one, again next one is equal again green. What happens here? Again electrons are again emitted only. Okay, so whenever again yellow color is used, no photoelectrons. Okay, next one, red also used here, no photoelectrons, okay? So what is the logic here? The wavelength of this all colors maximum is equal to red color and frequency is maximum for the violet only. So again, nu v is greater than nu r. Okay? So whenever yellow light is used, so for this color, again no electrons are ejected. So automatically again this frequency of red is less than of this yellow. So hence no electrons also emitted. See this example also. Okay. 25 marks, 30 marks. Okay. Again next one. 14th question. In a photoelectric experiment, the stopping potential for the incident light of wavelength. This wavelength is given. That wavelength is equal to 4000 angstrom unit. The stopping potential is equal to 2 volt. So V0 is equal to given 2 volts and like lambda is equal to given 4000 angstrom. Just 1 second. Again, question number 14th one. See the question once again. This lambda is equal to 4,000 angstrom unit. And like stopping potential is equal to 2 volts. V0 is equal to 2 volts. The wavelength is changed 3,000 angstrom. So again, this lambda 1, maybe second one is equal to lambda 2. So this lambda 2 is equal, what happens here? So this one is equal to 3,000 angstrom unit. So what is the V0 2 is equal here? V0 2, no need of find out this value. Is it more than or less than only? Is it more than or less than? The stopping potential. More than? Whenever here this HC by lambda, suppose frequencies increase means what happens? This kinetic energy is also increase. Clear? Frequencies increase means, so nu is proportional to kinetic energy. So whenever this frequencies increase, kinetic energy is also increase. So nu is proportional to kinetic energy. What is that equation? EV0. Stopping potential is also increase. So I draw graphs also. So in this case, what happens here? So this is equal to first graph. Like this is equal to second one. Like this one is equal to third one. So this what happens here? This is equal to again. So nu 1, this is the nu 2. This one is equal to nu 3. This is equal to V0 1, V0 2. This is equal to V0 3. So what happens? So whenever the frequency of the incident light is increased, so what happens? This stopping potential is also increase. But in this question, so this wavelength decrease. Wavelength decrease means what happens? This frequency increase. Logic clear? Since nu is proportional to 1 by lambda, so lambda value is decrease. Lambda is decrease means nu is increase. That one small sentence also. In the question, wavelength decrease. Note down. In the question, wavelength lambda decrease. Just simple lambda decrease. In the question, lambda decrease. So then, frequency of the light increase. Frequency of the light increase. So hence, stopping potential also increase. Stopping potential also increase. So now what is the answer? More than 2 volts. Some student taking the paper, I can doing the sum also, I can time wasting half an hour, 1 hour also here. Simple logic only. Okay, next 15th question. 15th one. Fifteenth question. The maximum kinetic energy Ke max of photoelectrons emitted in a photoelectric cell again changes, varies with the frequency nu. So simply Ke max value is taken on y-axis. This one is equal to Ke max. So Ke max on y-axis, and again frequency is equal to on x-axis. So this one is equal to nu naught, threshold frequency. So what is the slope of the graph is equal to? Slope of the graph is equal to Planck's constant. How the Planck's constant value? Slope of the graph is equal to. The slope is equal to, slope is equal to say h by e. Again next one. Again this slope, what is that equation here? Again from this graph is equal to, slope is equal to. So Ke max by nu. Okay. So Ke max is equal to that equation here, EV naught. EV naught. So do this one. Equate this both. We will get answer Planck's constant. Again 16th question. Completed. 16th question. The stopping potential V0 versus frequency nu. So what is the threshold wavelength is equal? Threshold wavelength is equal to. Find the threshold wavelength. Let's do this calculation also. This C is equal to say C is equal to nu lambda, nu naught, lambda naught. Question number 16th. Yes, please do this calculation. So what is the lambda naught is equal to C by nu naught. This graph nu naught is equal to given 5 into 10 to the power of 14 hertz. Yes, do this calculation. Again, C is equal to 3 into 10 to the power of 8. So this is equal to 3 into 10 to the power of 8 meters per second. Again, nu naught is equal to 5 into. So 5 into 10 to the power of 14 hertz. So do this calculation. Next one. But answer is in angstrom unit, okay? Not in meters. 17th question. In the photoelectric effect, electrons are emitted. When the electrons are emitted, whenever the suitable frequency of the light is incident on the metal surface, so then only these electrons are ejected. That suitable light of frequency, nothing but this threshold frequency. This light frequency is more than a threshold frequency. Which option is given? The fourth option. So only if the frequency of incident radiations is above the certain threshold value. Next, 18th question. 18th one. If the wavelength of incident light falling on the photosensitive material decreases. So wavelength decreases. Same as previous question also, same one model given here. So wavelength decreases means stopping potential again increases. So 19th question. So monochromatic light of frequency is given. 19th question. So this frequency nu is equal 6 into 10 to the power of 14 hertz. Please note this value also. The frequency of incident light is equal to 6 into 10 to the power of 14 hertz. So the power is equal, P is equal to, so 2 into 10 to the power of minus 3 watt. The number of photons emitted on the average. So N by T is equal to how much? N by T is equal to. Well, what is the equation? This power P is equal to N into E by T. So directly E value is H nu, since nu is equal to given. So E into H nu by T. Shall we do this calculation? So N by T, what is that equation? N by T is equal to say, so power by H nu. For H nu, you have to use H is equal to 6.62 value. Like nu is equal to given. So what is the option? The fourth option correct only. You got the answer? Next one. 20 question. If the energy of the photon corresponding to a wavelength, so lambda 1 is equal to given, this lambda 1 is equal to 6,000, angstrom. Again, next one. This energy is equal to E1 is equal to 3.32 into, so 10 to the power of minus 19 joules. Okay. Second case. So whenever this wavelength lambda 2 is equal 4,000 angstrom unit. So what energy E2 is equal to how much? This also one different only. So again frequency changes. So what is the energy in second case is equal to how much? Same metal surface, W naught is cancelled. So what is that equation? This energy, first option, this is Hc by lambda 1 is equal to, so W naught plus energy, this lambda 1 is given. Kinetic is not asking here, only energy of the photon is given. So what is that equation? E is equal HC by lambda. Simple equation, okay now? So E is HC by lambda. So HC is equal to constant value, E is proportional to 1 by lambda. So E is proportional to 1 by lambda. Please note down. So E2 by E1 is equal to lambda 1 by lambda 2. One simple question. Note down. E2 by E1 is equal to lambda 1 by lambda 2. Okay, next one. But again, in the question again given electron volt is given, but we will get the answer in joules. Okay, joules, converted electron volt. Next, 21st question. For photoelectric emission from the certain metal, the cutoff frequency is nu. The cutoff frequency means the threshold frequency is given, so that value is equal to nu. Cutoff frequency nu naught is equal to nu. The radiation of the frequency is equal to 2 nu. Okay. So what is the maximum possible velocity of the emitted electron will be? This cutoff frequency is equal to nu. The radiation of the frequency is equal to 2 nu. So what is energy equation? So energy is equal to W plus. So kinetic energy K E max. What energy? What is equal to H nu? Okay, H into nu. So nu is equal to how much value? This is equal to 2 into nu. This is the value. So kinetic, this energy is equal to H nu. But in this question, nu, this frequency is equal to 2 nu. So 2 into nu. So which value is equal to W? What is that equal to H nu? Since this cutoff frequency is equal to nu given here, H into nu, plus kinetic energy Ke max. So half mv square. So you have to find out maximum possible velocity. So velocity means simply you have to use this equation. So half mv square. So what is that equation? It will come left side, this will become negative. So 2 h nu minus h nu. So 2 h nu minus h nu is equal to say half mv square. As I do this remaining calculation, h nu is equal to half mv square. Okay, next. 22nd question. 22nd. So what is the option of this one? Second option. Next one. Photoelectric work function of the metal is equal to 1 electron volt. So W naught is equal to 1 eV, 1 electron volt. The light of wavelength is equal to given lambda is equal to. So lambda is equal to 3000 angstrom unit. So lambda is equal to 3000 angstrom unit. The photoelectrons comes out with velocity is equal to. You have to find V max value only. Same this formula here. So this W naught is equal to given 1 electron volt. So lambda also given. What is the formula here? So 12,400 by again 3,000. So which value is equal? W naught is equal to 1 electron volt. Again this kinetic energy is equal to half mv maximum square. I think maximum students also did same this one, but they got answer mistake also. So what is the reasoning mean? What is the reasoning means here? This 2 zeros cancel here. So 124 by 3. What is the value? 124, 30. So 3 1 ja, 3 4 ja. Okay, next one is equal to 1, 3 1 ja, 3. Okay, remaining how much here? 0.3. Okay, now? Okay, this is equal to 4.13 by 30 minutes of direct value. So 3 minutes 41.3. Again by 10 is there. So 4.13, which value is equal to 1. Again plus half mv maximum square. Half mv maximum square. 4.13 minus 1 is equal to, this value is equal to 3.13 is equal to, so half mv maximum square. So 90% students simply they are doing like this one. So directly V max is equal, what is that equation? So V maximum square is equal to 2 into, so 3.13 by m. So m is equal to how much value? This is equal to 2.3, 2 into 3.13 by m is equal to 9.1 into 10 to the power of minus 31. I think 90% students they did like this one here. Answer will come exactly value. But this value is equal to 12,400 by 3,003. What is units is equal to electron volt only? But again this is equal to mass is kilograms. So now we have to convert this value into joules. So this is equal into so 1.6 into 10 to the power of minus 19 joules. Compulsory you have to mention this value also. Same this also again. So 1.6 into 10 to the power of minus 19 joules. So this one is equal to 3.13 electron volt. So this is equal to 3.13 into 1.6 into 10 to the power of minus 19. I think 95% students they did like this one without this electron joules only. Now we will get correct answer. Yes, do it. This is a 4.13 electron volt. So which is equal to 1 electron volt. Answer not exactly nearly value 10 powers only. So maybe 1 point something, no need here, 10 powers. Got answer? Next one. 23rd question. 23rd question. The maximum velocity of electron emitted by the light of wavelength lambda is given. So what is the work function is equal to? So any values are not given. So this energy is equal to hc by lambda. Since lambda is equal to given, work function is equal to pi. Again, next one is equal to the maximum velocity means kinetic energy is equal to half mv maximum square. V maximum square. So what is the kinetic energy equation? So half mv maximum square is equal to hc by lambda minus pi. Clear? So what is the V maximum square equation? V maximum square is equal to, so this one is equal to 2 by m into, here LCM is given, so this is lambda hc minus lambda into pi. Is it given answer? So now what V max is equal to that equation? So V maximum is equal to square root of 2 by m into hc minus lambda pi by lambda. Which option was? Third option. 23rd. So remaining sums I will explain next class. Highest how much? 43. Congrats, 43 marks, 43 questions, okay? Who? Thank you all of you.